Hello, we're going to have a look at something called gradient-intercept form. Okay, now recall this is what a straight line looks like. Okay, it's a blue line here on top of a Cartesian plane that we've been looking at. Now we can write a mathematical statement to say what this line is. That statement's called an equation. Okay, and the equation looks like this: y equals ax plus b. Okay, where y is the y-axis coordinate, x is the x-axis coordinate, a is the gradient, and b is the y-intercept. The two things that you'll have to work out today are the gradient and the y-intercept. Okay, so here is some questions. Now an example: if the slope is 2, the gradient is 2, and the y-intercept is -3, then what does that make our equation? Okay, well, our equation always looks like this: y equals ax plus b, and a is the gradient and b is the intercept. So our answer is going to be y equals gradient 2x, and our y-intercept was -3, so that becomes take 3. Okay, what if that was actually +3? Well, that would become y equals 2x. That hasn't changed, but our intercept is now 3, +3, so it's going to be +3. Okay, so the next way you could work it out is from the graph. So we need to work out what the gradient is. Okay, gradient was rise over run. Okay, so I can see over here on this graph, rise 2, run 2. Okay, if I pick those points, so 2 divided by 2 makes it 1. Now I can see on the graph what the y-intercept is. Okay, the y-intercept is where it intercepts the y-axis. Okay, so where the line crosses over the y-axis, and we can see it's right about here. Okay, at 2. So that y-intercept is going to be 2. And putting it all together, the equation becomes y equals, okay, well, it's going to be y equals 1x plus 2, because the gradient is 1 and our intercept is +2, positive. But I can simplify it because 1x is just x, so I can get rid of the 1 and make it look nicer. Y equals x plus 2. Okay, and then the last one, okay, is if I give you 2 points. So here's the 2 points: 4, 3, and 2, 5. Okay, well, first thing you need to work out is the same as these two ones. You need the gradient and the y-intercept. Gradient and the y-intercept. First thing you're going to work out is the gradient. Remember, you did y2 take y1 over x2 take x1 for the gradient. You're going to do the same thing here. Find out what the gradient is using that. Okay, 5 take 3 over 2 take 4, that becomes -1. Then we're going to work out what our y-intercept is. Okay, so our y-intercept, when we do that, we are going to write down what we know, which is this one here: y equals -1x plus b. The -1x comes from where our gradient was. It was -1. Then what I'm going to do is I need to have b by itself, so no other letters I don't know. But I have a y and an x. I actually do know one of the y's and x's on that point, on that line. It's one of these guys. Okay, both of these are points that are on the line, and they each have a y and an x. Okay, so I'm going to go and pick one. I've picked this point here, and I'm putting in what its y is. Its y is 3, and its x is 4. And then that becomes y equals -1 times 4 plus b. And I can solve that now because I've only got one letter that I don't know. So that now, if I go -1 times 4, that's -4. Okay. And move him over to this side, that becomes 3 plus 4 equals b. So 3 plus 4 is 7, b must equal 7. Putting it all together after that, I just grab, I leave, because it has to look like this, y equals ax plus b. Okay, we've got y equals -1, the gradient, x, and then b was 7, so it's going to be plus 7. So the equation for the line that goes through these points is y equals -1x plus 7. So I've shown you 3 ways of finding the equation today. First, if I give you the gradient and the intercept, you can put it together. Second, if I give you the graph, you can find out what the gradient is and you can work out where it crosses and put it together. Third, if I give you 2 points, you can work out the gradient like we normally do. And then a new procedure to find the y-intercept, okay, using a gradient and one of the points that we know. That's what you've got to do today.